session today. It's an idea or a topic that I spent a lot of time working on, both my research and my education as a extension wildlife educator here at Iowa State. And I'm a native of the Corn Belt. I've bounced around to every corner of the Corn Belt, landed right here in the middle of it in my professional career and in my studies, and it's a landscape that I'm really passionate about. And so that's what I'm going to be talking about today, is the opportunities that I see for wildlife conservation alongside other priorities for resource stewardship and working landscapes. I think I'm aware, obviously, that the 100th meridian, as John Wesley Powell and lots of others have taught us, changes a lot of things in North America. And so what applies here in Iowa doesn't always apply, of course, all the way out to the western border of Nebraska. But I think the ideas that we're going to talk about today definitely apply to the working agricultural landscapes of eastern Nebraska and many of the species that we share stewardship responsibilities and conservation priorities for across the border. So that's what I'll be talking about with a sort of agricultural row crop production angle. And then I wanted to sort of mention, I'm going to be presenting a little bit of research, a little bit of my own, a little bit of mostly other people's research. But mostly what my talk is almost like a cheerleading exercise, I think. And I think that's sort of my role as a wildlife educator, is that I think sometimes we have to step back and see what we do well and where our opportunities are going forward to address these big societal challenges that we have, like water stewardship, biodiversity conservation, climate change, and issues of diversifying engagement, natural resource management, stewardship. And so those are the kind of things that I'm thinking about. And this talk today is sort of just a broad overview of one of those areas where I think there's a lot of potential to advance our work, the work to conserve wildlife diversity and wildlife conservation in our working landscapes, and our work to address water quality. So that's where I'm going to go. I'm going to start with the story that we all are most familiar with, and that's the story of all the good stuff that professional wildlife biologists have done in North America. We think about many of our conservation successes. These are the things we teach about in our classrooms across the wildlife programs across the country, the successes that we've had. Of course, lots of baggage came out of the Industrial Revolution, and we led to the extirpation or near extinction of many of these species, like 4 of these featured here: the North American river otter, bald eagle, white-tailed deer, and Canada goose. And through work primarily through cessation of take, the protection of these organisms from unregulated exploitation or the detrimental effects of things like DDT in the case of bald eagles, we've reversed those population declines. And that was led, of course, by state wildlife agencies and citizens and others that were interested in protecting and restoring these populations of, in many cases, charismatic species. But there's been all along this sort of intractable problem, these other species that aren't seeing the same population increases or success that we saw with the 4 and the other examples of high profile conservation success stories. And this is particularly true of farmland wildlife generally. So that, of course, isn't a definition that we agree upon universally, but I think of farmland wildlife as those species that have traditionally been able to exist on the margins of our production operations, or the margins of places where people have lived in North America for hundreds or thousands of years, in disturbed areas associated with agriculture or other land management practices. So 4 pictures, my fence post bird pictures there at the bottom: a bobolink, a western meadowlark, a northern bobwhite, and then, of course, white-tailed jackrabbits, the 4th one. And lots of other examples exist, and we can explore data that sort of describe these trends. We're all familiar with the plight of the eastern population of North America of monarchs, and there's certainly a farmland wildlife species that's seen declines in their population since the 90s, and we know that these declines have been even more substantial over longer time periods over which empirical data don't exist. Here is some data just from the North American Breeding Bird Survey, where I'm just comparing and contrasting Nebraska and Iowa here on just some conspicuous bird species that we have data sets for dating back to the 60s that I would classify as farmland wildlife. And you can see, Iowa and Nebraska, we share the exact same trend with brown thrashers. Western meadowlarks have been on the decline, grasshopper sparrows on the decline, and bobwhites primarily declining, though recently increasing, associated with some favorable weather conditions. I couldn't find any empirical data for white-tailed jackrabbits, but I know from some of the work that your diversity group does, that white-tailed jackrabbits are species of greatest conservation need over there. And here in just 2 other Midwestern states where I know there's some empirical data of this farmland wildlife species, that there's been pretty appreciable declines in their populations again. And this is what I mean when I say this intractable problem of farmland wildlife populations declining, even though we were able to restore the wild turkey and North American river otter, white-tailed deer, and other case studies. Now, I think it's important to step back and say, well, or maybe it's tempting to say, well, this has been driven by expansion of agriculture. That's certainly true in some places of the world where agricultural expansion per se is the driving force in biodiversity declines. But in the Midwest, that's really not true, particularly at the timescales that we're talking about these changes in farmland wildlife occurring. So here's some data from the National Agriculture Statistics Survey that just make this point that farming has been in Nebraska and Iowa for quite some time, and it's of course not going anywhere. This is just the land area, or proportion of land area in farm based on the National Ag Statistical Survey questionnaire. And I raise this point only to say that it isn't necessarily changes in necessarily the footprint of agriculture that are driving these declines. Rather, it has to do with the nature of the way agriculture is employed on the landscape. And so here's a picture of a section of land in central Iowa in the 1930s, during which we have aerial imagery of the entire state. And here in this landscape where farmland wildlife were relatively abundant, those species that I've introduced, we find a diversity of production practices here. Here's a hay harvest operation, an oats harvest operation, in relatively small fields. Here's a livestock production facility in the 1930s, and you could imagine if you were a species, a grassland breeding bird, that pasture would make for pretty good wildlife habitat. And so in this way, in those kind of pictures that I just showed, we think about farmland wildlife, those species that weren't really exploited a lot, and were existing on the margins of our farm. They were essentially a byproduct of the land stewardship practices that we use, or agricultural practices that we used at the time. Now, if we watch this same section of land, what it looks like today in central Iowa, we can see, of course, why it is that those intractable declines have occurred. And so here's that exact same landscape now transition from a period where wildlife were essentially a byproduct of production practices, and farmland wildlife were a byproduct of production practices, into today's modern landscape. Of course, we all know what this looks like on the ground. We have really large equipment. We have a small number of crops that are profitable and therefore used in our landscapes. And we, of course, know that our livestock production enterprises have moved primarily out of the pasture and onto concrete, as pictured here with a modern egg production practice. And so in these landscapes, we, of course, are reminded that this is where our challenges exist for addressing these intractable declines of farmland wildlife, such as these case studies that I've presented in a huge number of the species of greatest conservation need that we're all concerned about in our work to conserve state wildlife resources. And so what I want to talk about the rest of the talk today is how coincident with these intractable declines in farmland wildlife has also been proliferation of challenges related to water quality, related to the exact same factors that are driving farmland wildlife population declines. And so here, across similar timescales that we've been examining or considering, is modeled estimates of nitrate delivery in the Mississippi River Basin. And of course, we've seen, coincident with these periods of population declines in farmland wildlife, an explosion in nitrate exports out of the Mississippi River Basin into the Gulf of Mexico. Here's a watershed by watershed accounting for those relative nitrogen yields. And of course, we find that the majority of this nitrogen is coming out of the heart of the Corn Belt in Iowa, Illinois, Indiana, and Ohio. But of course, eastern Nebraska, Minnesota, and other states are contributing meaningfully as well. And annually, this is creating these hypoxic conditions in the Gulf of Mexico. So there's these big, almost international challenges related to Gulf hypoxia due to nitrogen export from the Mississippi River Basin. But water quality challenges also exist in our own backyards. Here's just a picture. It doesn't take a lot of work to find an account like this. a picture of a blue-green algal bloom driven by eutrophication in local waterways here in Iowa from a few years ago. And in a really quick Google search this morning, I didn't struggle to find the same story there in Nebraska. Basically, anywhere we have these intensive row crop production enterprises, we tend to find challenges related to eutrophication and thus harmful algal blooms. And so these two challenges, this is where I see the opportunity for essentially addressing multiple challenges together in our working rural landscapes. And here I'm going to show you 6 pictures of why. So the challenges to address that history of enriching nitrogen export to the Mississippi River Basin and the history of harmful algal blooms in our watersheds look like these pictures here. So a wetland, a prairie, a riparian buffer, a strategically integrated patch of perennial vegetation, livestock production on sustainably grazed pasture, and strategic integration of perennials and row crop fields, among a litany of other conservation practices that address nitrogen loss or phosphorus loss in watersheds, while also potentially making wildlife a byproduct of production practices. Again, if we impose the imperative for all landowners to address these downstream issues associated with nitrogen, phosphorus, and other contaminant losses in our surface waters. And so in this way, and this is what I'll spend the rest of the time talking about, I find a lot of promise for opportunities to bring farmland wildlife back into working landscapes, in working landscapes that work to address not only the production opportunities of agricultural landowners and producers, but also the responsibility to responsibly steward surface waters, primarily related to nutrients. And so that's what I'll explore. And we want to dig into detail how specifically wildlife may be able to benefit from practices that we know also address water quality challenges. So I spend a lot of time working and thinking about water quality, and I hear the word water quality used a lot. The water quality applies to many different things. And so I always like to make sure that we're on the same page and give you my definition of what I'm specifically thinking about with water quality. One, I just want to mention that water quality can be the composite impact of many different things that find their way into water and create impairment challenges for humans or other aquatic life. This can be things like contaminants, bacteria, sediment, and nutrients. I often like to explore each one of these because they're all an important part of addressing and stewarding surface waters more responsibly, and groundwaters for that matter. But I'm going to just talk today primarily about nutrients, given the time and given that that's the primary focus of interstate collaboration for water quality conservation efforts. So nutrients, primarily nitrogen and phosphorus, that I'll talk about, come from cities and they come from farm fields. I'm going to focus primarily today on farm fields because, as I showed you, 90% of Nebraska is in farms and 85% of Iowa is in farms. And that's an area where we have a lot of potential to make big landscape changes that address water quality and wildlife conservation concerns. That focus on nutrients also, of course, comes from what I've already hinted at, this Gulf hypoxia efforts, these coordinated multi-state efforts to address challenges related to Gulf hypoxia in the Gulf of Mexico, originating with this 2008 plan that called for every state with major contributions to hypoxia to write a nutrient reduction strategy. And so that's what sort of guides efforts in Iowa to achieve a 45% reduction in nitrogen and phosphorus in our surface waters. Now, I know Nebraska doesn't have the same sort of coordinated mandate with the Gulf of Mexico, but again, the practices and principles apply. And in some eastern Nebraska watersheds, these actions for water quality can be consequential, certainly for the Gulf of Mexico. So I'm going to break it down and talk about nitrogen and phosphorus next, and I'm going to use nitrogen and phosphorus to structure my discussion about how wildlife will respond to these water quality conservation practices. So nitrogen moves, of course, as nitrates. It's mobile in water. That's why it's most problematic in tile drain landscapes, where it moves through the soil surface into subsurface tile and out as fast as we can get it off to the Gulf of Mexico. The way to address nitrogen is to allow for natural denitrification processes that occur in wetland ecosystems and also in riparian and riverine systems. In essentially, anytime nitrate-rich water finds an opportunity to slow down and spend time around a carbon source, it's going to be released as harmless into gas. And so what we need to find on our working landscapes to get this 45% reduction in nitrogen and phosphorus is places for water to slow down and denitrification to occur. It's a professional waterfowl biologist and one that happens to be obsessed with ducks. For anybody that knows me, that is a scenario that I'm quite familiar with. Places where water can slow down and spend a lot of time in a single place, where there's a lot of carbon, like for example, emergent macrophytes or submersed macrophytes or carbon-rich soils, like wetland ecosystems. So here's in Iowa, there's lots of efforts ongoing to target wetland restoration or wetland creation in specific watersheds where they're going to be introduce nitrate-rich water to allow for denitrification to occur. This is an example of one of these wetlands that's been constructed in Iowa for denitrification. This is another picture of one of these wetlands from an aerial photograph. And the reason I'm showing you this wetland is because that's where this swan was captured. This swan was born on this wetland designed for denitrification. And then the Iowa Department of Natural Resources, this guy, Tyler Harms, tied that tracking device around that swan's neck, released it back out onto that wetland. And of course, before it could fly, it spent all of its time around that wetland where it was born. But then it soon fledged off that wetland, restored or created for denitrification. It fledged into the landscape. This is Iowa State's, close to Iowa State. Iowa State is a city down here in the bottom right. And these are all the points where this swan foraged, primarily in crop fields, but also in wetlands. And it actually sort of had a knack for finding these wetlands restored for water quality. Here's two more where it flew to and foraged during its first fall of life. And here's a third one that I was able to find in this landscape. So in this way, this wetland dependent bird happens to be the byproduct or the beneficiary of a conservation practice targeting nitrogen reduction in working landscapes. We also know from some nice monitoring work that was done a few years ago and cited here that many Iowa species of greatest conservation need amphibians like northern leopard frogs, cricket frogs, and tree frogs all breed in these wetlands as well. I've done some research in these wetlands, and we know that spring migrating ducks use wetlands and intensively farmed landscapes to fuel their migration back north to the wintering area or to their breeding areas. And some really cool work in Canada, not on nutrient treatment wetlands, but on wetlands generally, finds that it's a place for floral diversity and thus a safe refuge for a diversity of native bees. So wetlands in that way can be really important for addressing many conservation challenges, not just nutrient reduction. We find the same story in nutrient reduction practices like restoring Oxbow wetlands. This is a Oxbow wetland where they removed post-settlement alluvium and found 44 to 47% nitrate reduction. That's consistent with that Gulf hypoxia goal. And we of course know that these Oxbow wetlands provide really important habitat for wetland-dependent wildlife like these migrating ducks, and also in some places critical off-channel habitats for fish, including the endangered Topeka shiner pictured here from some Fish and Wildlife Service monitoring. I mentioned I'd also talk about phosphorus. Phosphorus doesn't have that gaseous form, so it's a little bit harder to deal with once it's moved out of our fields. So the challenge with phosphorus is to keep it in the fields, to keep the soil on the ground. And so the practices that we'll talk about for phosphorus have to do primarily with perennial vegetation. This is Dr. Lisa Schulte-Moore. She's a wildlife biologist and a professor here in our department at Iowa State. And she and some collaborators have done some really neat research over the last decade or two on integrating perennial vegetation into row crop fields at varying levels. And they find that 10% of a row crop field in perennial vegetation, like prairie, can reduce phosphorus movements, can reduce surface water nitrates, and can also provide really important habitat for pollinators in row crop fields and also a diversity of grassland breeding birds.
2 minutes.
We find the same thing, of course, that in phosphorus reduction for associated riparian practices. like saturated riparians or upland buffers like shown here. And many different species of birds use these, and also many different species of butterflies found in a study in Minnesota. Will, I heard you say something. Was that
Yep, 2 minutes, Adam.
2 minutes? Perfect. So the last thing is what Dr. Little just talked about, and that is that many times these conservation practices and working landscapes can be good for water, it can be good for wildlife, it can be good for the farmer. We know that many corn and soybean production have really tight production margins. That's what's depicted by how close these lines are here in this figure. And some research in Iowa found that about 12% of Iowa's cropland annually operates at a loss. And so applying the principles that Dr. Little just talked about, we can find these areas where crop ground is operating at a loss, remove them from production, and allow for denitrification to occur in those places. We've done some monitoring here in Iowa where we dispatch armies of students out to find monarchs and birds, and we found lots of species of greatest conservation need are using these small patches of perennial vegetation in crop fields. And we're also finding lots of milkweed in these small patches, and of course, many monarchs as well. So this is just some statistics that I'll kind of fly through here as I wrap up. So there's lots of conservation practices to address nitrogen and phosphorus in working landscapes. Here's a bunch of them. Some of them are just sort of amalgamated into large categories, but some of these have a real meaningful positive footprint for wildlife and wildlife diversity. In targeting those areas and applying what we as professional wildlife biologists know about the importance of native plants, the importance of natural functioning ecosystems, and the importance of connectivity, like Dr. Little talked about, could result in a landscape where wildlife become byproducts of production practices again. So that's what I wanted to go over today in my presentation. Really look forward to taking additional questions that you have.